Hello and welcome to this section of Calculus Extra Practice with Integration. Here we're going to continue working integration by parts, and we've been working our way into more and more complicated types of problems. Now, I think most of you would agree that you have a pretty good grasp of integration by parts by now, but I think you would also agree that as techniques of integration goes, integration by parts can be a little bit involved. I mean, you have lots of little steps that you have to do before you can actually even tackle the real integral. And then you just have to hope you don't make any mistakes, because then otherwise it's totally destroys your chance of actually being able to solve the problem. But what if I told you that there are actually several types of problems that you will almost be guaranteed to see on your exam, where you have to do integration by parts, not one time, but 2 times, and maybe even 3 whole times in order to get to the right answer? Then you could see how the complexity of the problem multiplies. I mean, if doing integration by parts 1 time to solve a problem is difficult, then doing it twice is just going to add 2 times the amount of chances for you to screw something up. And if you have to do integration by parts 3 times, then there's lots and lots of chances for you to make a simple error and get some problems, something wrong on your test. I can tell you right now, I remember getting these kinds of problems on my exam, so I can almost guarantee that you'll see them. Let me show you what I mean. Let's say we have integral x squared times e to the 4x dx. Believe it or not, this is going to require us to do integration by parts 2 times. And you can't see it at first because you don't have experience yet to know, but the big clue here is that you have an indestructible function, which is the e to the 4x, and you have the destructible part out in front, the x squared, but it's squared, right? This is going to tell you your clue, and I don't expect you to know that now. We'll see it as we do the problem. But what this is going to end up telling you is that you're going to have to do integration by parts 2 times. When you first learn this stuff, you can't see it, but you'll understand what I mean in a second. So what I want you to do is proceed exactly like you would normally proceed. There's nothing that you do special. You do everything the same. So let's say u is equal to x squared. That's what we've typically been doing. And let's say dv is e to the 4x dx. So we don't really change our plan of attack. We do everything the same way. Du with respect to x is 2x. So what we have here is du is equal to 2x dx, and that's what we want to see. And then we have over here, to find v, is going to be the integral of e to the 4x dx. And we've done these things so many times, I've kind of hinted, it's probably good for you to remember it's 1 over the derivative of the exponent times e to the 4x, because that's indestructible. It doesn't really go away when you integrate it. And so what we have is everything we need to solve this problem. We have this guy, the du, we have v, and we have dv. So, so far we're, on the right track, and we're very happy that we're, almost done with this problem, or at least we think it is. Integral of v du. So let's go ahead and plug everything in exactly as it stands. So u is going to be x squared. V is going to be 1/4 e to the 4x minus the integral of v, which is 1/4 e to the 4x du. Du is 2x dx. So let's go ahead and tidy this up and see where we stand. What we have here is the 1/4 x squared e to the 4x minus the 1/4 can come out, and the 2 can come out, and it's basically going to give you 1/2, because 2 over 4 is 1/2. So 1/2, and then we still have an x in here, so it's x e to the 4x dx. So study this for a second and make sure you understand